Değerli katılımcılarımız, 9. oturumumuz Otomasyon ve Optimizasyon adlı oturumu sunmak üzere Elif Dağtekin'i sahneye davet ediyorum.
Good afternoon, welcome back everyone. We are here with the 9th session, and I'm Elif Dağtekin. I'm a fourth-year student at Middle East Technical University, Geological Engineering, and this session is centered on automation and optimization. It's a critical area for the future of mining operations. Our first speakers are Freddy RAMIREZ and Dmitrii FOMENKO from Sandvik SRP. Freddy RAMIREZ is an accomplished engineering professional with extensive experience in project management, digital transformation, and manufacturing systems. Dmitrii FOMENKO brings years of expertise in automation, sales development, and team management. Together, they will deliver a presentation on automation connectivity system. The floor is yours. Bu arada simültane tercüman programı imkanımız bulunmakta. Kulaklıkları simültane kabini yanından temin edebilirsiniz. Welcome.
Thank you very much. Good afternoon, dear attendees. And first of all, we would like to thank you for this opportunity to deliver this information about digital portfolio that company Sandvik can provide our customers for their screening and crushing solutions. And of course, special thanks to our partners and official dealers in this region, the company Tessim, for ensuring this opportunity. So let me introduce the speakers today. The Freddy RAMIREZ, a life cycle manager in the region Southern Europe, Middle East and CIS, and myself, Dmitrii FOMENKO, technical sales manager in Europe, Middle East and CIS. We are both from the Sandvik Rock Processing Technology Solutions. Sorry. Doesn't work. During the nearest 20 minutes, we will provide you with a brief overview about the automation and connectivity system for crushing and screening solutions, as well as about our new SEM platform as a core of the digital ecosystem for the whole crushing and screening circuit. If we have some time in the end, we will show a short demo about how the interface of SEM platform look like. And yeah, but if not, please feel free to come over to our booth C20, where we are capable to answer all of your questions and provide all the information you required. And we will start with screening solutions. In this sense, it is highly important to mention the changes that have been happening to the Sandvik portfolio during the last 3 years. Before that, Sandvik was represented only with their portfolio for the well-known linear motion, circular motion, and grizzly screens, which we call S-range now, and which were suitable mainly for the infrastructural plants and small mining. But now, for the last years, Sandvik has acquired 2 big mining businesses, which forms our portfolio and made it, I would say, one of the most extensive portfolio all over the world. The SK range, formerly Kwatani, the South African screening company, which holds the leading position in the African market and brings to the market such kind of solutions like multi-slope screens, rectangular separation, round separators, and some other specific applications. And we also acquired the mining business of the famous German company Schenck, which is well known with their solutions in terms of the robust screens for heavy-duty applications for big capacities within mining and steel industry. Yeah, all of these solutions are forming a really extensive portfolio, and if previously we could call Sandvik as a primarily crushing company, now crushing and screening are equally developed at Sandvik, which make absolutely sense because this equipment is equally important for the mining companies. And yeah, if we are talking about screens, despite it looks at first sight simple, It consists of a plenty amount of different details in terms of spare parts for metal structure, in terms of drive units, which are 24/7 under vibration in heavy conditions and heavy duties for mining customers. And in a lot of cases, screens are playing crucial and critical role for the entire mining plant. So basically, if we are talking about challenges during the operations of screen, we can form it in one question for the maintenance and reliability specialists within mining companies: how to minimize downtime and avoid unplanned shutdowns, so not to let down the whole mining plant. It brings another question. To do this, we need to optimize the process, as well as to set up a proper maintenance strategy to keep the uptime of the machine as high as possible. To do this, we need to understand what kind of service actions are required and when these actions are required. And of course, to understand this, it's better to know the condition of the equipment, and it's much better to know this in real time. To do this, to help our customers with these challenges and answer these questions, we developed our automation and connectivity system for screening solutions, which was adopted, the prototype was adopted from the Schenk mining business. If we are talking about hardware, the system consists of the following part. The heart of this system and the measurement unit of this system is the state-of-the-art wireless and self-powered sensor, which combines the new technologies expressed in the magnetic mount and energy harvesting functions, which can receive energy from the shaking process of the machine. Depending on the size of the machine, we can use different amount of sensors, which are basically placed on the sidewalls and exciters. Yeah, so basically this sensors measures the screen motion in all directions simultaneously on the right side and left side, and as well as on the exciter. Yeah, to ensure the stable and reliable connectivity and network reliability, we are using transceivers with an active antennas. Depending on the complexity, we use 1 to 3 transceivers to ensure this stable connection and to seamlessly transfer the information from the sensors to the gateway and flow unit. In flow units, all calculations are made. And in case of any deviations from the threshold, it gives generates alarm. And we will see how does it look like in SAM platform a little bit later. Basically, ACS system is a part of the whole digital ecosystem. We will talk a little bit later. And data from ACS system can be easily exported to the digital cloud infrastructure and SAM platform to provide our customers with all necessary reports, dashboards, analytics, and suggestions how to proceed with the maintenance of the machine. As well as it can be exported to the plant control system, because we have some cases when some safety functions abounded to this system for the protective purposes. Long story short, as a conclusion for automation connectivity system for screening, we developed the new system, consists of the state-of-the-art sensors, which gives our customers the full flexibility in terms of the installation, in terms of the data transfer. We created the robust architecture and sensor synchronization and many of different advantages. Altogether, it gives our customers the main benefit. You can early detect if something's wrong is going with your machine and prevent this until it's getting serious and until you have an unplanned shutdown. That's the first one. Besides, it's good to have a data-driven maintenance and maintain the machine not according to the certain schedule, but according to the machine's condition, to keep its uptime as fast as possible. Basically, that's all I wanted to say about the automation and connectivity system for screens. And now I pass the floor to Freddy to tell the same about crushers.
Thank you, Dmitrii. It's a pleasure to be here. At Sandvik, we want to be recognized as the leader when it comes to provide crushing solutions for the mining industry. We understand that our customers are demanding nothing more than the best operational efficiency, maximum utilization, and a machine that is not creating a headache when it's in the real sturdy operations down there in a mine. For this, we have a comprehensive offering that goes all the way from our 800 series equipment that includes the latest and greatest advancements in digitalization and also in hardware. These are basically used in secondary applications. Also going through our 400 and 600 series, which are smaller yet more flexible, that can be used in tertiary applications. Not to forget, of course, our jaw crushers and gyratories, which are basically used in large-scale mining applications. And last but not least, our horizontal and vertical impactors, which are used in special needs. My name is Freddy Ramirez, and I'm really happy to be here and walk you through some of our digitalization and show you how our hardware and software work together to be able to offer you the best experience when it comes to crushing for mining. The typical challenges that we face in mining operations have to do fundamentally with the ability to achieve the maximum operational efficiency. At the end of the day, we get a machine and we want the machine to last the best, to last the longer, and to be able to provide a consistent output throughout the whole life cycle. Preventive and predictive maintenance is of the essence. We don't want to stop operations. We want to make sure that we understand when it's time to change components. We want to characterize the processes, and understanding the life cycle of those, it is of the essence. Liberation of ores in mining is an important element to be able to allow downstream processes to be as effective as the processes upstream. And of course, the ability to connect to monitoring systems is also quite important. SCADA is one of them. And we achieve this through our, as we mentioned, the ASC, or automation connectivity systems for crushers, which in a nutshell, it consists of having strategically located sensors in our crusher to be able to understand what is happening, what is the health of the machine at any moment in real time, that at the end of the day you can see at the tip of your fingers while you are here enjoying this event. You could also be seeing what is happening at your mine or quarry. Through the ACS, we're able to detect abnormalities. We are able to also monitor crushing size, particles, pressure, temperature, recirculation, and at the end of the day, if the machine is being utilized at its full. Some of the features, as I mentioned, of the ACS have to do with enabling the operator to have a holistic crusher control, to have automation in terms of adjusting the wear ratio, or through enabling to adjust the close size setting to have the same particle as the machine is going through the normal wear and tear. Also, it allows to have an automatic settings and, of course, monitoring of key parameters. This, together with smart hardware integration, allows to provide the best maintenance service with minimum effort and time. ACS, at the end of the day, it is the backbone of what we're going to see as a SAM in the following slides. The takeaway of having control systems of this nature is that allow us to have overall equipment effectiveness to its maximum, to also allow us to have remote support. That is an important aspect, especially when the equipment is down there in a mine, to be able to understand time to do maintenance, to optimize mean time between failures, mean time to repair. All this is achieved through our ACS. And ACS, when it comes into what we call SAM, which is nothing more than our asset management system through digitalization, ACS is the backbone and is what it allows to have our digital platform. In a nutshell, the signals coming from both our crushers and screens are going into this architecture and allows you to see at the tip of your fingers what is happening with your operations. It's a digital assistant that allows you also to be able to understand not only the health of your machine, critical alarms, we will see that in a demonstration a bit later, but also to enable to have e-commerce functions so that real time right there, the operator or different personas dealing with the machine are able to order pieces or order key components on the spot so that you don't interrupt your operations. An important aspect is the ability, as I mentioned, to provide remote support, meaning that while the equipment is working, we can start working in the backbone or in the back end, providing insight and absolutely data so that you can understand how your machine is performing and conduct predictive and preventive maintenance. An important aspect as well, and we know this for a fact, operating with many customers, that availability of manuals, availability of components is of the essence, right? After all said and done, at the end of the day, we have to be able to have the manuals right there, and SAM allows you to have that. You don't have to deal with big manuals, but everything is at the tip of your fingers. When it comes to the architecture, and I will hand this over to Dmitrii, it is an important element that to keep simplicity. I hand it over to you, Dmitrii. Thank you.
So, thanks, Freddy. When it comes to the architecture, as it's written, it's a reliable and quite simple architecture that combines both crushing and screening circuit in one system and in one digital infrastructure. Basically, we got the information from sensors, from crushers and our screens. Then, through the gateways, via transceivers, we process this information and we can send this to the plant control system to ensure the protection of the equipment in case of emergency, as well as we, via Wi-Fi or cellular network connection, we can transfer all the information to the SAM cloud, which is the protected infrastructure where all the customers can have an access and to have all the information regarding their processes, regarding graphs, regarding trends and so on, to all the tools to make the maintenance decisions, to estimate the current conditions of the machines. And as I said, it forms the single infrastructure for the entire crushing and screening circuit. Important to say that this access to the SM platform is not only available to the desktop, on the desktop devices, but also on the mobile devices. That means that you could have all the information anywhere and anytime, independently on where are you located now. So that combines all necessary dashboards to make the maintenance decision as fast as possible. And in the end of the presentation, we would like to provide you with a short demo of how does the portal looks like, the SAM platform. It consists of plenty of information that are required for maintenance and reliability team, different graphs, different trends during the time, which you can zoom in or zoom out if you need to see the certain time range. Yeah, that's really important for the maintenance and reliability specialists to estimate the screen performance, to estimate how does the machine looks like in terms of the reliability. Besides, it has the system diagnostic, I mean the automation and connectivity system itself, including the signal strength, including the battery charge, temperature, sensor temperature, uptime of the sensor, so you can see the information about this. And important thing is, that's really important for non-trained staff like operators and so on, because it generates alarms which are easy to understand, because it provides you with the description, potential reasons, and possible actions to mitigate this problem, which is also valuable. And the same, more or less the same, we see for crushers, but with their own specific, with their own KPIs, which are relevant for crushers, also graphs that could be zoomed out, zoom in upon the time, the performance characteristics, the utilization, energy consumption to estimate how energy efficient is, and of course alarm logs with the description of the reason, consequences, and potential action. So altogether, this provides our customers fully insight about their crushing and screening fleet and fully flexibility in terms of the decisions they can make during the operation of these machines. Yeah. So yeah, that's plenty of different trends. And also it's important to mention once again the e-commerce platform. So you can see which spare parts are recommended to purchase for this exact machine when you have any problem with this machine. So we would like to thank you for your attention, and if you have any questions or required for some additional information, please come over to our booth or contact us or our dealers in the region, Tessim Company. Thank you very much and wish you a great day.
Thank you so much. Thank you to both of our presenters so much for this informative presentation. Our next speaker is Michael Adam DROZD, the President of Detox and Treatment Consulting and General Coordinator at YPT. He will present on understanding the impact of carbon on your gold recovery. The floor is yours.
I think I'm going to go over to the ramp.
I can help you. Okay.
Thank you. Thank you, everyone. My name is Michael DROZD. I work in Turkey a lot with YPT. Would the YPT people please stand up? At any time during the discussion, you can talk to them. If you want to ask a question in Turkish, they will translate it for you. Feel very happy to be here. And let us say, in our last 3 projects, we have gone with Sandvik crushers. So I think you should give the Sandvik people another hand. So I couldn't see it. So I tried to do a translation as we go. So the top is in English. The line below will be in Turkish. It started out as Google Turkish, but I had our people translate it properly. So I always start with this point. No matter what your wife tells you or your life partner, in carbon, size and hardness matters. Let me clarify before I get thrown out of the meeting. When using carbon, you either have to, you are impacted by either the fluidization for a heap leach operation or with the size of the carbon in a CIP or CIL. And carbon is holding your gold, and you want to make sure that you get all the gold you can. So the quality of carbon is very important. The price of carbon is very unimportant, and that's the old carbon salesman point of me. But the price of carbon, which is about $4 a kilogram, doesn't make any difference because when the carbon is expended from the system, it has gold on it. And that gold is worth way more than the carbon. I did tell you shape matters, didn't I? Yeah. Okay, well, if carbon is too flat or breaks too easily, you will lose carbon. As engineers lose gold, it is lost revenue, which should be avoided at all costs. And more of this we'll discuss later. Now, this is going to be a very general talk because a lot of people in the industry only look at carbon as something black that's in the process. They're not worrying about its strength, its size, different things like that, which are important and doesn't take very much effort and has a very large value return if you take care of your carbon. I mentioned in my first statement, hardness refers to the carbon resistance to breakage and attrition. Can you shut this off? I'm getting feedback. Can you shut this off? Oh, okay.
Is it okay?
Had sounds. Okay. This is fine. I was getting some feedback, and that really bothers me if I'm in the audience, so I didn't want it to happen. The hardness refers to the carbon's resistance to breakage or attrition, and to carbon surface area because gold and silver are absorbed on the carbon surface. 1 gram would fit in the palm of your hand. Carbon, of a good carbon, has 1,050 square meters of area. That is a mind-boggling amount of area for something that is so small. But all of that area is internal to the carbon pores. So why does this matter? All coconut shell carbon, the carbon of choice in gold industry, and in the early years of carbon recovery, the industry tried everything. Almond shells, peach pits, plum pits, coal, coconut shell, etc. And coconut shell was found to be the best carbon because it had the most micropores. And the gold is absorbed within the micropores. And that's why the carbon of choice throughout the gold industry, except people who use Norit, is coconut shell carbon. The way coconut shell carbon is made, they take they crack the coconuts, they take the meat out, which they make oil and coconut to eat, and they take the shells, which is a throwaway product. Then the char people are a bunch of entrepreneurs, go dig a pit, put a pipe in there to let some air in, throw the coconut shells in the bottom, set up a way to start a fire, and bury the coconut shell. So the slow burning of carbon in the coconut shells is pulling the oxygen out of the cellulose of the carbon. And that material then being removed is leaving the coconut shell microporous pores in the material. That char is then sent to an activator where it is heated up in a neutral atmosphere. Neutral atmosphere is usually carbon monoxide coming from the burning of the cellulose. Since it's in a deficit in air, it will make carbon monoxide, not carbon dioxide, or steam. If there's any moisture in there, the steam comes up and the oxygen is displaced. At 800 to 850 degrees C, the cellulose material used in the interior carbon oxygen in the cellulose fibers and makes the activated carbon shells. If the carbon is activated too long, greater internal surface is produced and the carbon becomes weaker. It breaks. As the carbon particles hit themselves or if they hit the agitator, etc., they will break. When they break, they're smaller particles. They're going to go through the screen and they're going to go into your waste. Everybody has fine carbon systems, but it's very hard to get rid of your fine carbon. Most people don't want it because of the mercury associated, especially in Turkey. So there's such a thing as too much surface area because the weaker surface area carbon decrepitates and ensuing loss of your product gold. It's incumbent upon the process engineer to balance the size, shape, and hardness and activity of the carbon. The lower the activity, if you look at the CTC, carbon tetrachloride, which means you take a specific weight of carbon and you pour carbon tetrachloride in it, and then you pour that material across the screen and put it on a balance, and you see how much weight it increased. A CTC 50 means that it absorbed half its weight in carbon tetrachloride. It is a use in the industry to discuss surface area. And the activity of the carbon is then maximized over the life of the carbon. That's why you regenerate. You don't reactivate. Reactivation takes you to too high a temperature and you start consuming cell wall again, weakening your carbon. So very specifically in regeneration, we stay between 550 and 600 degrees C because what you're removing from the carbon to make it regenerate is the oils that have been absorbed from the processing. How do you make a good decision on carbon you use? You start with the carbon supplier's specification sheet. See next page. Coconut, char, granulated carbon, and in the position of water treatment, they use powder carbon. And this is what about a gram of carbon looks like. This is a nice clean plant where the project is being used. The picture below is a not so clean plant. And I could not ever figure out why that particular manufacturer put that picture on the internet, because it sure as hell made me not want to buy their carbon. This is a CIC carbon column, and this is a CIC carbon in operation. You move your solution up from the bottom, the carbon fluidizes, and as it fluidizes, the carbon stays in the tank, the gold in the solution is moved onto the carbon, and the solution goes down to the next column. If your carbon is too small, the fluidization rate is too high, and you keep moving the carbon downstream, but when you operate it, the solution with the high grade goes from the top to the bottom. The carbon goes from the bottom to the top. It's a counter-current operation for recovery of the gold. This is some information on products I pulled off of the internet. You can see different sizes. Almost all carbon comes out with a 5% moisture, because that's absorbed from the atmosphere. Some of these tests they give you really don't mean anything, but it looks sexy. The hardness test. The hardness test is you take your carbon, you put it in a screen, and you put steel balls on top of that screen. And then you go and put the carbon in a rotap for a specific period of time, and the amount of carbon that comes down under the screen is then considered the attrition. That is good for road base, but it's not good for carbon, because most carbon, when it breaks down, doesn't break down below 80 mesh, which is 200 microns. And they use a 200 micron screen. No attrition, look at that, you know, we're 95%, we're 98%. That is not a good test, but every carbon manufacturer will give you a ball pan hardness test. That's by that ASTM number. You have to have your own set of tests. This is the set of tests that we used and I helped develop at Barrick Gold, the Gold Strike project, and used throughout Barrick. Barrick, one of the largest, if not the largest gold producer in the world. And we looked at the screen mesh material, but we also had slotted mesh screen come out, because carbon breaks into platelets, because if you saw that the coconut shell, they're fairly thin. When it breaks, it'll break along that plane, and you will have particles that are thin, but are larger than the screen on the square mesh, and it won't pass, and it looks like you don't have any particles that do that. But if you look at the slotted screens, you'll see that that screen analysis moves down much further, and almost all carbon screens in a gold plant are slotted screens. So you have to be aware of what you're doing. You can't just say, well, my square mesh screen says this stuff is good. And then you go in and you lose 18% of your carbon as you wet it and push it across your first primary screen. Happened to me more than once. They also looked at particle size. They take a microscope, they look at a field, and they count flats, they count smalls, and they do this 10, 12 times, and then average it and say this is what they see for the particle sizes. Their tests, we do a single point isotherm. Take a solution, take virgin carbon, put it into the sample, see how much gold it absorbs. Then you take your used carbon that has been regenerated and you put it into a similar test, find out what your recovery is, the removal is. So you take the removal of the two, virgin being 100%, what you get in operation being the other percent, and it'll tell you how active your carbon is. Very simple test, very good information. It tells you if you're regenerating properly or if you're not. Very simple things to do without big fancy equipment to tell you it's this or that. And I'm not against big fancy equipment, but I'm more interested in equipment that does a job and doesn't cost you too much money. Yeah, I'm almost done. This is the gold absorption that you can see. With copper in the process, the amount of gold you have is going to decrease. And sometimes people are using 2,000 grams per ton or whatever. You have to know that all the metals are in there to come through. This is from Marsden. It's a strip curve. It tells you how many bed volumes you have to achieve stripping at what temperature. This is a very good table for an operating engineer to have. From the procedure information, that's just a boilerplate. Of course, you're paying attention, you see mixed dimensions and left some information and conversions out. Ultimately, the parameters are correct, the equipment is sized properly. If you can stop by our booth and we can discuss the details. I thought I had 15 minutes left, or 4 or 5 minutes left, but I have 2. So if you have any questions, I'll be glad to answer them at the booth. Thank you. I can go downstairs easier.
Okay, I can help you out if you want. Okay. I would like to thank Michael Adams-Droz for the presentation. Our final speaker is Martin RUGFELT, Director of Next Intelligent Solutions at WEIR Group. With experience in AI-driven solutions and optimization, he will discuss processing optimization using AI. The floor is yours.
Thank you.
Thank you.
Hi, everybody. Very nice to be here and see a lot of people here. I'm probably the one standing between a talk and a lunch, so I'll see how we can get along with that. So one thing about me is that I've been working with artificial intelligence for the last 18 years, so long before AI got hip and cool and easy to sell, which is another side of it. And I've started several AI companies along the way. The last one, Sentient AI, I managed to sell to WEIR Minerals 1 year ago. So we're just coming up on the anniversary of that. And as now within WEIR, I have the title of Director of Intelligent Process Optimization, which is very convenient given that exactly the topic of my little talk about AI and optimization in minerals processing. All right, so I wanted to take a step back and look at AI first in general, because this is a technology that will have an absolutely incredible impact on our society and on mining and on all industries. And if we take and make a little comparison to the internet we all know has made a huge impact in our lives, in our worlds, in our business. But that's a technology that is only really about communication and search. And still, all of these internet companies have made their businesses out of that kind of simple technology. And if you compare that with AI, you have a technology that is infinitely more powerful because it can do a lot of what we people can do. Can see, hear, talk, predict, optimize, etc. So an incredibly important technology. And I'm going to say to everybody that if you haven't really considered what you're going to do in this space, you better get active now. And what's happening is that we have a technology that is exponential. So it grows really, really fast, and it just accelerates. And I've been doing this for 18 years, as I said, and we're standing on each step as it goes up, and it just goes faster and faster. The challenge is that people are not necessarily evolving equally fast as the technology. So we're getting a gap between them, and that causes stress. Stress in terms of business, but also in people. And it is important to think about this when we're looking at the technology. But it's also important to see the other side of things and get active when it comes to this technology, because it creates a vast amount of opportunities. And if you take back to the story about internet, those companies that got active with internet early on, they had a lot of value and made a business out of it. The ones that did not get active and use the opportunities, they failed when it came to internet. There's a lot of talk about chatbots and what we can do with that. And all of the focus on AI has come to pass on that area. But AI is so much more than the LLMs and the chatbots. You have a technology that, as mentioned before, can do what we people can do. But it can do a lot more than that too. It does optimization better than us. It can help us with scientific discovery and evolution. So it's going to be a technology that impacts everybody from all kinds of angles. But there's also a lot of things that you can say about it. And there's an expression that not all things that glimmer are gold. And the same goes for AI. So there's a big difference between AI and AI. And I thought this might be interesting for you to reflect on. Because if you look at this graph, you have benefits on one axis and complexity on another axis. I've tried to generalize a little bit about the different types of AI you find out there. And it can be really important to make the distinction. So on one level, you have visualization, which is actually not even AI, but is often sold as AI. You have predictive analytics, so simple, very much a man-driven type of analytics that becomes predictive. You have specific predictions that are more advanced and more complex, but also gives a little bit more value. You have the APCs, which are well known, based on linear approximations and have these parts of it where you have to update them continuously. Then you have custom AI solutions, and custom AI solutions, they're very much based on domain knowledge, and usually has sides to them that are you have to update them and you have to work with them because they are fundamentally based on the domain knowledge that you have underneath it. Then you come to the ones that really look at the dynamics of the underlying process. And this is really important when it comes to process optimization. So there you make a big difference between the other types of AI that you need in order to get it to work with the dynamics of the system. So then you're looking at the more complex types of AI like reinforcement learning and these types of things. And then you also can get a lot more value out of it. It is more complex, but you get a lot more value. So I thought this was hopefully a little bit useful to get an idea of what it could look like and things you should be looking for when you're evaluating various projects. All right, so let's get into what you can do with this in a processing plant. So there's a lot of different types of things you can do. from equipment monitoring and analytics, and taking it to the next level, you have the predictive maintenance type of things and anomaly detection. Then we get to AI-based intelligent assistants and things like that that can help you with optimization of the processes. And that's the production side here in the middle. But you can take it even further and integrate it into other types of processes that are things like debottlenecking with the AI and so on, and integrate that into your tools. And using these kind of more advanced AI technologies to simulate the processes and get a really good view of your process. And finally, you can take it to full plant optimization, then basing it on the intelligent assistance and these kind of technologies and simulations as you go all the way to a holistic plant optimization. All right, so if you're considering doing AI investments in these kind of technology, I thought it would be useful to just summarize the kind of benefits we're looking at. So on one type of these are the very obvious one, the process optimizations that you see every day. Increasing throughput, stabilizing PAT, reducing cost, and also reducing increasing the equipment availability, so we're monitoring and these kind of things. But you can also use it to augment your own staff. Just as we do with these chatbots and so on, we get help, we get assistance. And if you combine that with your staff, you can augment them, so you can make all of your staff become much more efficient. There's another side of it that isn't talked about very much, is that AI can also be used as a replacement for certain CapEx investments. So you're considering an extensive build-out to your plant, you might want to consider AI first to increase that performance significantly on the way. And obviously, AI can also use with reaching your ESG targets and similar things. So a wide variety of reasons why you should be looking at AI for your optimization of your plants. And one topic I want to get into, which is the intelligent assistants. So we hear a lot of talk about intelligent assistants and agents in AI. This is something we have been working with for a long time and done a lot of research on for the last few years in my company. And we've now used that to create intelligent assistants for processing plants. And what they can do is they can help you with extensive advice on production, such as strategic planning and other strategic decisions. But it can also go all the way down to minute by minute or second by second automated and autonomous decisions in the plant. So it has a wide range of capabilities. I wanted to look at a case, in this case around HPDRs. But before we get into the actual case, just to give you the background of how we reason around AI and the value proposition that it can bring you. So on one side, we have all of the well-known strategic drivers, such as the declining ore grades, the green transition, and your ESG targets, but also the fact that there is, generally speaking, a lack of people in the industry, experienced staff. And we also have the very operational side of things with ore feed changes, drift and change to your equipment, and you want to keep track of your cost, etc. But you can also consider things like more advanced production strategies. And if you want to do, so this is what we had in mind, all of these things, and what we said, what can we do with AI to make this really work? And that's where we created these intelligent assistants, where we bring together the industry expertise of WEIR with the AI expertise of my team, software expertise, to create a solution that is dynamic, that can at any point of time make sure that the process is continuously updated and continuously optimized. And we provide this as an intelligence assistant that will help reach your goals when it comes to your P80, lower your cost, reaching your ESG targets, reducing the wear of the equipment, and also obviously increasing the throughput. And this is made available to all of the users of the systems, from the operational staff to metallurgists to plant managers, etc. So 2 examples of this. One example is an HPDR intelligent assistant. And if we look at what it can do, we're looking at things like ore grindability soft sensing. And soft sensing is a concept that not all are maybe familiar with. It's a situation where if you do not have the ability to put a sensor in a particular place, it could be difficult to do that, or it could be expensive. You can actually, in many cases, create a virtual representation of this sensor. So it's like a virtual sensor, or what we call a soft sensor. So we use that extensively in these solutions. By combining mathematics and AI and the data from the process, we can reach this level. We do product size estimations, we do various predictions, but we also help the metallurgists with what-if scenario planning, so they can play out and simulate what is going to go on in the process, so that they can make intelligent decisions around how to optimize the production. And that is in order to reach the goals that we're looking for: stabilized P80, reduced energy consumption, and increased throughput. So these are typically the kinds of things you can get from these kind of intelligent solutions. Another example is a mill circuit equivalent, so a mill circuit intelligent assistant. There you get things like advanced insights to your product size, your circulating load, and throughput and product particle size. And we do various kinds of predictions in order to get to there. In the end, the idea is the same. We need to get to the goals of the processes. In this case, maintaining the product size, reduce variability, increase recovery, and minimize energy. So all what you would want from these kind of processes. So let me finish this off by demonstrating quickly what this would look like and can look like in the case of an HPDR intelligent assistant. So the kinds of goals that you have when you're looking at that for an HPDR is to get set point recommendations, or if you want, have them automated in an autonomous set point generation. Alerts for process drifts, alerts for disturbances, help with stabilizing your standard operating procedures, WEIR monitoring to keep track that you make the targets of when you're going to do your next maintenance on the equipment, and so on. So there's very good reasons why you would want to do this. And if we look at this image, we see a range of different highlights. So this is the kind of interface that a operator would have, or a metallurgist would have, to the actual process. So at the furthest away, we have the P80 target and measured and estimated. We have the throughput KPIs. These are the targets that we want to make sure that we optimize for. On the other side, we have speed and pressure. And as the ore feed changes and there's disturbances and so on, the process change, then it will automatically identify that. So on a continuous basis, it tracks this evolution, and then it allows for the operator to immediately execute the recommendations. It will even give you alerts, obviously. If something really goes off track, it should be notified earlier, and if you have it automated and autonomous, it obviously happens faster. But the tool is not only for the operator, it's also for the metallurgist. So in the case that, which is usually the case, that you don't have all of your data digitalized. So some of these things are coming from lab samples, for instance, in which case the metallurgist can input that, simulate what's going to happen when that takes place, update the model and send it in. So we make sure that even non-digital data is used to update the models, so keep it accurate. And finally, we will also help the metallurgists with simulating these processes so that they can look into the future and predict what is going to happen to the process and get a really good view. So we call this what-if scenarios. They can play out several scenarios of what's going to happen. Oops, that was an extra. So I wanted to finish this presentation off by just saying a few words about what we're doing at WEIR. When it comes to this, we are mostly well known for our pumps and cyclones, maybe for the HPDRs too. But what we've been doing for the last few years is putting a lot of effort into acquiring capabilities in AI. We've even acquired 2 companies. One was mine, Sentian AI, and the other one was Motion Metrics. So we have a big team of AI people in the company. We've had a lot of experience, and this is crucial for AI solutions. You have to have the experience. And we've combined that in order to create these solutions. And already today, we at WEIR can offer solutions all the way up to there, and we will soon also deliver the end-to-end holistic processing plant optimization. So, I don't think we have any time for questions, or? Any time for questions, or we're good? Yeah. If you want to talk to me more about this, please come and visit us in the WEIR booth. We're at the end of the hall over there. And I personally will be here for another hour, but the rest of the team will be happy to discuss this with you. So thank you very much for having me here.
Thank you so much. Thank you so much for sharing this fascinating presentation. I would like to extend my sincere gratitude to all our speakers for their valuable contributions to this session. I hope everyone found the discussions inspiring. Enjoy the rest of the program. Thank you.
Konuşmacılarımıza ve moderatörümüz Elif Dağtekin'e teşekkür ediyoruz. Saat 14'e kadar öğle aramız mevcuttur. 14'te oturumlarımıza geri başlayacağız.